Okay, in this chapter, we're going to study chapter 5, time value of money. And time value of money is one of the most important topics in finance. So in this lecture, we're going to learn how to determine the future value of an investment made today. And also we're going to learn how to determine the present value of cash to be received at a future date. And also we're going to study how to find the return on investment and learn how to calculate how long it takes for an investment to reach a desired value. So here are the basic definitions. So on a timeline, present value refers to earlier money on the timeline. Let's say at time 0. That's present value. And future value is later money on the timeline. Let's say at time t. Let's say you may have $100 today or $100 at a later date, time t. And these are not the same dollars. You'd rather receive $100 today and then $100 later. So they are different currencies. The same number of dollars at different points in time are different currencies. To see this, let's consider a simpler example. Currencies used in different countries. So let's say you have 100 US dollars. This is the US dollars. And you also have 100 Canadian dollars, also 100 Australian dollars. And they're not same dollars, but they are different currencies. So in order to compare this, you have to convert different currencies into the same currency. So you may convert Canadian dollars to US dollars and Australian dollars to US dollars. So you need exchange rate. So let's say 1 Canadian dollar is equal to 0.76 US dollars, and 1 Australian dollar is equal to 0.72 US dollars. So 100 Canadian dollars is equal to 76 US dollars, and 100 Australian dollars is equal to 72 US dollars. So in total, you have 248 US dollars. Okay, just like currencies used in different countries are different currencies, the same number of dollars used in US at different points in time are also different currencies. You cannot directly compare them. So you need exchange rate called interest rate. Interest rate is the exchange rate between earlier money and later money. And we're going to study how these are related. by interest rate. So that's the concept of time value of money. So first we're going to see future value. So suppose you have $1,000 today. So you're going to invest this for 1 year at 5%. So you want to know how much you'll have a year later. So if you invest $1,000, 1 year later, you're still going to have this $1,000 plus you're going to earn interest on this $1,000. So 5% on $1,000 is $50. So in total, you have $10, $50 a year later. How about if you leave the money in for another year? Then how much money will you have 2 years from now? Okay. So it depends on how interest is computed. Okay. So there are the simple interest, and also there's compound interest. There are two types of interest. So after one period, it depends on how interest is calculated. So using simple interest, so you still have this. From the previous year, you earn interest on your principal, which is called so you earn interest on your principal. So you earn $50. So in total, 2 years later, you're going to have $1,100. Okay, using simple interest. But if you use compound interest, in year 2, so you still have $1,000 and $50 from the previous year. Plus you earn interest on your principal, so you earn $50. In addition to that, you earn interest on interest. So you earn 5% on $50. So you earn the extra $2.50. So you're going to have $1,102.50 using compound interest. So using compound interest, you earn interest on interest. Whereas simple interest, you only earn interest on your principal. So let's formalize this. So using simple interest, so in year 1, so you earn, so you have this principal plus you earn interest, the present value times R, that's at time 1. At time 2, you have this present value plus you have 2 of this, you have 2 of this, and for an arbitrary time t, you can generalize this to the future value is equal to present value plus present value times R, which is the interest, times t. Then you can simplify this to present value times 1 plus RT using simple interest. How about if you use compound interest? For time t is the same thing, but things start to change after the first period. So you have the present value, you have its interest, you have 2 of this, and you have interest on interest. So this is equal to present value times 1 plus R squared at time 2. And this can be generalized to present value, the future value is equal to present value times 1 plus R to the raised to the power of t using compound interest. So compare this to using simple interest. So using compound interest, so here's your present value times 0 over time. Your future value will grow exponentially. Like this. Whereas using simple interest, your interest will grow linearly. So initially, there will not be much difference, but over time, because you keep earning interest on interest, the difference will be larger, become larger and larger over time. So that's the power of compounding. In today's financial system, we almost always use compound interest. So in this class, unless otherwise mentioned, we use compound interest. So here's the formula that I want you to remember. The future value is equal to present value times 1 plus R to t. So let's use this formula to solve the following problem. Suppose you have $500 to invest, and you believe that you can earn 8% per year over the next 15 years. So how much would you have at the end of 15 years using compound interest? So Let's draw a timeline. At T0, you have $500. And at the end of 15 years, so you're going to have 500 times 1 plus R, which is 0.8 raised to the power of 15. So that is $1,586.08. Okay. That's how much money you will have if using compound interest. How about using simple interest, where you earn interest of 500 times 8%, so that is $40. So you earn interest of $40 every year for 15 years, so that is $600. And your principal is $500. So in total, you would have $1,100. So that's a pretty big difference compared to $1,500.86 using compound interest. So that is the power of compounding that we just talked about. So this is why you want to start saving money when you're younger. Next, we're going to move on to the present value. So the second time value of money. So present value answers questions like this. How much do I have to invest today to have some amount in the future? So we can use our future value formula and then rearrange it to solve for present value. Then we're going to get this present value formula. So present value is equal to future value divided by 1 plus R to the t. Okay. So let's look at an example. Suppose you need $10,000 in 1 year for the down payment on your new car. So if you draw a timeline, time 0, and time 1, and you're going to need $10,000. And so you won't know how much you need to invest today if you can earn 7% annually. So we can use the present value formula. The present value is equal to future value, $10,000 divided by 1 plus R, which is 1 plus 0.07, and T is 1. So you get $9,345.79. Okay, so that's how much you need to invest today in order to have $10,000 a year later. Okay, let's see another example. Suppose you have a 1-year-old daughter, so it's a more mature example. So you want to begin saving for your daughter's college education. So you estimate that she's going to need $150,000 in 7 years' time. Okay, so in 7 years' time, your daughter is going to need $150,000 for college education. So you will start saving today. So if you feel confident that you can earn 8% per year over the next 17 years, so you want to know how much you need to invest today. Okay, so that's asking what is the present value of $150,000 today. So the present value is equal to $150,000 divided by 1 plus R, which is 1 plus 0.08 raised to the power of 17. So that is $40,540.34. That's how much you need to invest today in order to have $150,000. So that's the present value. So the process of getting the present value is called discounting. So that's why interest rate is sometimes called discount rate. Also, in reverse, the process of finding the future value is called compounding that we have seen earlier. So here's here two important relationships that I want you to understand. First, we'll give an interest rate. The longer the time period, the lower the present value. So T goes up, present value goes down because T is in the denominator. So if T goes down and present value goes up, they move in opposite directions. So in the previous example, instead of saving today, you wait 10 more years and save money. So you invest your money over 7 years, and you're going to need a lot more than this, to have $150,000. So earlier you save, the less money you need to invest. Okay? That's the first relationship. The second relationship is that for a given time period, you fix the time. The higher the interest, the smaller the present value. So R goes up, present value goes down because it's in the denominator. So I goes down, present value goes up. Okay. So in the previous example, interest rate was 8%. If interest rate was lower, then you need more money to invest today. Okay, so to summarize, so here's a future value formula. Because there are 4 variables in this equation: present value, future value, interest rate, and number of periods. So if we know any 3 of these variables, then we can solve for the fourth variable. So, for instance, the present value, we can solve this or rearrange this formula to solve for present value. Then you have present value is equal to future value divided by 1 plus r to t. So similarly, we can solve for r, and we can also solve for t. We can solve for r to find the return on the investment, and we can solve for t to calculate how long it takes for the investment to reach certain value. So let's first look at the interest rate. So we are solving for r. So suppose you're offered an investment to allow you to double your money in 6 years, and you have $10,000 to invest. And what is the implied rate of interest? Where you have $10,000 today, in 6 years' time, you can double it to $20,000, and you're interested in the return on this investment. So you can use this future value formula. So present value is $10,000 times 1 plus r to the 6 equal to the future value, which is 20,000. So we can divide both sides by $10,000. That's 1, that's 2. So 1 plus r to the 6 is 2. Then we can raise both sides to the power of 6. And that's 1. So 1 plus r is 1.1225. So we can subtract 1 from both sides to find r is 0.1225. So interest rate r is 12.25%. Okay. Next, we can solve for t. To make some space here. So you want to purchase a new car, and you're willing to pay $20,000. So you're willing to pay $20,000 for your car, and you can invest at 10% per year, and you currently have $15,000, and you want to know how long it's going to take to have $20,000. Okay. So again, you can start from a future value formula. So 15,000 times 1 plus r, which is 1.1, raised to the power of t, and is equal to 20,000, which is a future value. Okay, so can divide through 15,000. That's 1. That is no 4/3. 1.1 to t. Okay, so t is in the exponent, so we can take logs on both sides to knock this guy off. So t is log over 3 divided by log of 1.1, which is close to about 3.02 years. So that's how long it's going to take for you to grow your $15,000 to $20,000. Okay, so that's all I want to talk about in this lecture. Thank you for watching. I'll see you next class.